Optimal protein for performance, presented by Kristal Casas. Protein is composed of subunits called amino acids. 20 amino acids are needed for the formation of other variant proteins. There are two ways the proteins can contribute to or can be used during exercise. The utilization of alanine is amino acid which is converted into glucose in the liver, which is then created to make glycogen. The conversion of some amino acids into compounds which are used in the bioenergetics energy system. The optimal protein intake is important for athletes to have nutritional knowledge and practice the optimal nutrition recommendations for the improvement in performance, recovery, and overall health. The United States daily recommendation protein intake for the average adult is ranged between 0.75 to 0.80 grams per body weight in kilograms. The American College of Sports Medicine supports the recommendation for protein in athletes to range between 1.2 to 1.7 grams per body weight in kilograms a day. This protein recommendation is for both endurance and resistance training exercises. Using myplate.gov, developed by the U.S. Department of Agriculture, sources of protein could be obtained with the consumption of animal sources, plant sources, and alternative sources, which include protein powder supplements and protein snacks. The protein quality could be measured using the PDCAAS. It is known that the highest quality score could be 1.0. The animal protein products like milk, whey, and casein and meats are known to have the highest quality score for protein. There have been several studies that have studied the differences between milk source protein intake versus soy protein intake. One study has examined between the consumption of milk protein and soy protein. It was found that the consumption of milk protein resulted in a greater hypertrophy in their athletes. Milk protein has shown to have potential to improve the adaptations from training. Another study was conducted for a duration of 12 weeks in college football athletes that were supplemented with 42 grams of milk protein per day when compared to a placebo group. It was shown that the football athletes had a 14.5 increase in the max squat strength than compared to a 6.9 increase in the placebo group. Studies comparing the benefits and effects of strategic protein consumption timing immediately before, during, or after exercise have shown to maximize muscle repair, optimize strength, enhance hypertrophy adaptations. Casein protein is naturally insoluble, which makes it slower to digest. During a 12-week study, two groups were compared to test for casein protein influence. Group 1, the casein group, consumed 1.9 grams per body weight in kilograms a day. They also consumed 27.5 grams of casein powder every night before going to sleep. Group 2, the placebo group, only consumed 1.3 grams of per body weight kilograms a day. The results showed that the casein group showed enhancement in their muscle mass and strength.
My subtopic in nutrition for improved performance in aerobic and anaerobic exercises consisted of optimal carbohydrate intake and its sources. Here, we would talk what carbohydrates are and how they affect individuals in their exercises. What are carbohydrates? Carbohydrates are the sugars, starches, and fibers found in our fruits, grains, and vegetables, and milk products that we consume in our everyday life. There are three macronutrients: carbohydrates, proteins, and fats. These macronutrients are essential for our body to function properly, and we require large amounts of them. All these macronutrients must be obtained through what we eat, and the body cannot produce them on its own. The function of carbohydrates are to provide fuel for the central nervous system and energy for our working muscles. They also prevent protein from being used as energy and enable the fat for metabolism. And carbohydrates are also classified as simple or complex, the difference being only how quickly the sugar is absorbed and digested in our system. It is recommended that carbs provide 45 to 65% of our daily calorie intake, since carbohydrates are one of the macronutrients that we most need, primarily for the energy and the fuel source they provide to all individuals. For those performing anaerobic training, a good diet would consist of high carbs and low fats. During an anaerobic workout, the body breaks down carbs to produce ATP. On the other hand, aerobic training is very beneficial to those who want to lose weight and improve oxygen consumption. So those performing this type of exercise, their purpose is to lose weight and decrease intake of carbs will help the body in burning stored fat for energy.
Vitamins. Vitamins function as metabolic regulators and influencing members of physiological processes for sport performances. There are different types of vitamins which work on different parts of the body. They also have different functions which all come together when trying to achieve an outcome for the human body. The less vitamins the body has can decrease the person's VO2 max and anaerobic threshold. However, with the wrongful use of steroids and amphetamines, vitamin supplementation has increased among athletes to enhance their performance, safety, and ethics. Vitamins are safe to use in athletes as long as they know how to control their intake and how they are used to correlate their training. Vitamins. Vitamin B1, B6, and B12. The body should consume more than a third of vitamins B1, B2, and B6. These vitamins can affect the serotonin levels in the body, which is a neurotransmitter for relaxation. Along with this vitamin group is choline. Choline is a neurotransmitter, in which case a lack of it can develop fatigue in a person. Choline will help with prolonged exercise routines, while it increases the blood levels at rest. Vitamin C. Vitamin C is water-soluble and present in the cytosolic compartment of the cell. Vitamin C works as an electron donor for vitamin E radicals generated in the cell membrane. The metabolic events from the initial damage results in muscle protein degradation with continued damage. The loss of calcium stability plays an important role in exercise-induced muscle damage. Vitamin B1. Vitamin E. Vitamin E plays an important role in preventing the free radical damage in the body that endurance exercise is known to cause. Free radicals are atoms and molecules that have an unpaired electron. They can damage the molecules important for cellular function use. However, there is evidence of free radical involvement in exercise-induced muscle injury. Vitamin E may not be able to prevent the muscle damage in those individuals without a vitamin deficiency. A deficiency of vitamin E increases the susceptibility to free radical damage and leads to premature exhaustion and a greater fragility of lysosomal membranes. A supplement of 100 to 200 milligrams of vitamin E daily can be used for endurance athletes in order to prevent exercise-induced oxidative damage. Vitamin E is contributing to the prevention of exercise-induced lipid peroxidation, since the result of vitamin E is mobilized from stored tissues and redistributed into the body to prevent oxidative damage. Vitamin E shows a greater influence of augmenting the neutrophil response to eccentric exercise.
Hi, this is Damian Soliz, and I'm in a group with Eblins, Kristal, and Flor. And this is improved performance in sports with fats and minerals. So on the first slide, we start talking about fats. Fats help in metabolic reactions. During training, fats help in quick recovery from injuries and lessen propensity for illness. Fat usually promotes a shift from omega 6 to omega 3, helping to enhance their overall performance. Most athletes use low fat. Intense exercise and respiration affects burning of fat. Fats have to be retained at least 10% because the body relies more on carbohydrates when exercising. As we continue with fats, the duration of an exercise affects the amount of calories burned. Prolonged low intensity exercises influences change for carbohydrates to fats as source of energy. Blood glycerol levels determine amount of fat required. An increase in the glycerol levels in the blood indicates hydrolysis has taken place. And small amounts of fats are required in the adipose tissues as muscles for aerobic exercises. And again, we continue with fats. Fat loading happens when there are excessive fats in the body. Most athletes have fat loading when they have high intakes of fat supplements to increase the levels of triglycerol. For the people not training, fat loading contributes to endurance and performance. For people not exercising, fat loading can lead to health problems, including the risk of diabetes. Intramuscular fat does not improve sport performance. Fatty acids from omega 3 or omega 6 contribute to the main source of fats in the most athlete bodies. As we finish talking about fats, I will jump to minerals. Most of the minerals used are sourced from vitamins. Popular vitamins include vitamin E, B1, B6, and B12. Vitamins serve as important in facilitating metabolic reactions. Minerals help in muscle contraction. Proper diet of minerals helps in the nerve impulse conduction and the oxygen transport as well. As electrolytes, the vitamins help substantially in the hydration process of athletes. As we continue with minerals, vitamins help in the conversion of sugars and proteins into energy needed by the body of an athlete or muscles to perform better. The help of vitamins in the repairing of cells is critical in the athlete's body. Vitamin B12 helps in building red blood cells and age conduction. Lack of vitamin 12 make the body feel weak. B1 and B6 help in energy production. And as we continue to the last slide on the minerals, other minerals needed by athletes as sports performance include magnesium, zinc, electrolytes, iron, omega 3, and some of the sources can be through supplements or natural foods such as spinach and oats, among others. So that concludes fats and minerals. I hope you enjoy our PowerPoint.